Okay, I'm going to do a couple of word problems using rationals, and the first one is a work problem, and there's many different ways to solve these. I solved them one particular way, but you could look somewhere else and see it solved a different way. So I'm going to show you the way I solve this. This is when you have something, for example, Joe is trying to fill his tank at his farm, and he has two wells. He has a less powerful one that takes 10 hours to fill it, and a more powerful one that takes 6 hours. How long will it take both pumps working together to fill the tank? So in this case, it's a work problem. I want to know it takes 110 and 1/6, but if they work together, how long it should take. So one thing is you should reason through the problem. If they're working together, it should take less than this smallest time here because it should be faster. There you have two pumps working. So if you get an answer greater than 6, that tells you that something's wrong with your answer. So the way I solve these is I look at how much they complete in 1 hour. So in this case, I have a less powerful pump and a more powerful pump, and then how long it's going to take them together. So I'm going to look at the amount the less does plus the amount the more does, and that should equal the amount they do together. So let's just say I use t, but you could use x. T is the amount of time it takes them together. Okay, and then what I'm going to look at is how much they complete in 1 hour for each one of these. So if it takes the first pump 10 hours, that means in 1 hour they've completed 1/10 of the work. Because it takes a total of 10, they've completed 1/10. The second pump, if it takes 6 hours, that means in 1 hour they completed 1/6 of the work. And they're working together, so we total the amount they complete, and this should equal the amount they complete together in 1 hour. I don't know that time, we called it t, but the amount they complete together would be 1 over t. So this is the problem I'm now solving. So setting it up might take a little bit more time, but once it's set up, the solving is going to actually be easier. So we're again going to look for the LCD of these denominators. So start with 10, 6, and the LCD of 10 and 6 is 30. Now they both do divide into 60, but if I'm looking for the smallest number, it would be 30. And then there is one variable, t. So this is the LCD, 30t. So I'm going to come over here, and just like we did above, I'm going to multiply all of these by the LCD over 1. Okay, and when I multiply, I get 30 divided by 10 is 3, so I get 3t plus, here 30 divided by 6 is 5, so 5t equals, over here the t's cancel, and I'm just left with 30. So you can see the math here is a little bit easier, and this is going to become 3t plus 5t is 8t equals 30. Divide both sides by 8, and I get 30 over 8. And because this is a word problem, I like to not leave it as improper fraction. So you could do a decimal, or 8 goes into 30 3 times, right, with a remainder of 6. So 3 and 6/8 I need to reduce by dividing by 2, and I get 3 3/4 of an hour. So make sure you have units. So you could do 3.75. And that answer makes sense. It is less than the 6, so it'll be much faster if they work together. Okay, let's set up this motion problem. This is the distance, rate, time, and I have a table already here. So we're going to fill it in. So Anne entered a race which required a run of 10 kilometers north and then a bike 120 kilometers west. Determine her running speed if she cycled 10 times faster than she ran, and the total race took 4 hours to complete. Okay, so this is going to come back in a little bit. So the total time. So first let's fill in what we know. The distance running was 10, and the distance biking was 120. I don't know the exact rate, but I know that she cycled 10 times faster, so that'd be 10r. And then I don't know her time. That's actually what I'm trying I'm trying to find her running speed, so we'll get to that in a minute. So this is her time running, and this is her time biking. So I'm going to write these two equations down. Just have to move this up a little bit. So I just erased all that. Let me just put that in real quick. Okay, so we're going to write these two equations that we just said. So I have distance equals rate times time, and over here I have distance equals rate times time. And then just like we did before, I'm going to solve for the times. So in this case, divide by r, and you get her time running was 10 divided by r. And over here, her time biking is 120 divided by 10r. I'm going to simplify that. These are both divisible by 10, so I get 12 over r. Just make this a little bit easier. Okay, and then this is what's important. The total race took her 4 hours to complete. That doesn't mean that the time running was the same as the time biking. The distances and speeds are much different. It means total time was 4 hours. So when you total something, remember that means you're adding it. So her time running plus her time biking is supposed to equal 4 hours. Okay, so we've set up the problem. We can now solve, and we can solve for r, which will help us answer her running speed. That's r right here. So that's what I need to find. So the LCD is actually just r. That's the only thing in the denominator. So I'm going to multiply everything by r over 1. Here the r's cancel, and over here the r's cancel, and I actually just get 10 plus 12 equals 4r. 10 plus 12 is 22. Divide by 4, and I get r equals 22 over 4, which is 5.5. And this is her speed, so about 5.5 kilometers. Yep, that's units per hour. So 5.5 or 5.5 would make a little bit more sense.